At this point, your game is more or less fully functional. Two people can play each other and look at the score to see who is winning. However, there is no concrete win condition. If the score moves beyond what the scoreboard can show, you'd have to restart the program to restart the game. That would involve flicking on and off the power switch once we load it to the actual circuit board, and in here we would have to stop the simulation and restart it. Um, to make it obvious when the game is over, and to make it a little more convenient to restart the game, let's create an endgame function. At the very end of our code, I'm going to type void endgame. And then, just like my other functions, I'm going to have an opening curly brace and a closing curly brace. And all of the code that's going to execute when my game ends is going to be right here. What should happen when the game ends? Well, it would be nice if the game restarted. What does that mean in our situation? It's pretty simple. The score needs to reset. What's the starting score in our situation? Well, to get the middle LED to light up, we need to reset the score to 3, the initial score that we have up here. So I'm just going to say score equals 3, semicolon. Okay. You can and should do other things in this endgame function. You may remember that I programmed my Tug-o-War game to blink the LED closest to the player who won. Since your circuit board is equipped with a buzzer, you could play a tone or even a jingle. You might even play 2 different jingles depending on who won. Whatever you decide, you would put the code inside this endgame function after this curly brace and before this one. Now that we have a function that does something when the game is over, we need to call it. The lowest score our scoreboard can register is 0. So that's the LED right here, closest to the left player. When the score drops below 0, we need to call the end game function. So let's add an if statement at the beginning of our show score function that calls the end game function. So right at the top of the show score function, I'm just going to put an if statement that says if the score is less than 0, then I would like to call the end game function. So again, when the program is about to show the score, when it's about to change which LEDs lit up, instead of having nothing show up on our scoreboard, it will realize that the score is too low to display, and it'll call the end game function, which resets the score. Let's go ahead and test it out and see how it works. And I'm just gonna play trigger happy with the red player here so that the red player loses points because he's clicking before the LED is green. And oh no, I clicked several times and the red player lost, the green player won, but the score isn't showing up on the scoreboard. That means this code here isn't working as intended. So to understand why, let's go ahead and use a serial print line statement, and we're just going to print the score to the serial monitor down here and run that code again. And I'll do the same trick where I make the red player push the score towards the right player push the score towards the left player, and when I click too much, you actually see the number 255 show up here. That doesn't make a lot of sense until you remember that when we declared the score variable way up here, we declared it as a byte. And a byte is a number that can only range between 0 and 255. So instead of going from 0 to -1, it loops around and it goes from 0 to 255. So what we need to do is, instead of calling this a byte, we need to change this and make it an int. I'm going to stop the simulation. I'm going to change the type of variable this is to an int. And now I'm going to start the simulation again. And I'm going to clear the serial monitor first. And then I'm going to start the simulation again. And let's see what happens this time around. And here you can see that we got a -1, which when we look at our if statement, -1 is less than 0, so it called to the endgame function, resetting the score to a 3, which causes the middle LED to light up. So this is the correct way to call the endgame function once we've set the score to being an integer variable type instead of a byte. Once you've run your code and tested it and verified that it's working, go ahead and commit it to Bitbucket and then add that same functionality for when the score gets too high, when it gets above the index of the last LED. Once you've gotten that worked out, go ahead and commit your last commit for the core functionality of your Tug-o-War program. From here on out, it's your choice on the different changes you want to make to your Tug-o-War program. You can add sound, you can change how long things take to happen. There's lots of different things you can do to customize the Tug-of-War program to make it just the way you want it.